and I'm delighted to introduce today's speakers. We have Dr. Helen Meese, founder and MD of the Care Machine and trustee of the Institute of Mechanical Engineers. And we also have Professor Richard Kitney, who is chair of Visbion, and he is professor of biomedical systems engineering and dean of the Faculty of Engineering at Imperial College London. Now, as you all know, the NHS Nightingale Hospitals are critical care temporary hospitals set up or scheduled to be set up in the UK as part of the response to the COVID-19 epidemic. And there are 7 in England, as well as similar hospitals in Scotland, Wales, Northern Ireland, and Gibraltar. And we're going to focus today on the engineering and engineering expertise and setting them up and running those, rather than the clinical aspects of them or aspects of how much they're being used currently or will be used in the future. So, if my panelists are ready, I would like to invite Helen first to take over the spot and tell us a bit about her role in setting them up.
Thanks ever so much, Mark, and it's really nice to take part in this event today. As Mark's already introduced me, my name is Helen Meese. I'm the founder and CEO of the Care Machine. We work with early stage startups and researchers to develop medical devices and technology. I'm also the vice chair of the Biomedical Engineering Division at the Institution of Mechanical Engineers. And I guess it's with that side of my experience that I was contacted by the Director of Healthcare Science in London, who I know quite well. And her question was, how can we increase the number of engineers we've got to support this new hospital we're going to build? And I kind of thought, okay, that's a bit of a blank sheet of paper, but let's have a think about it. And so over the last few months, I have been working very closely with the healthcare science team and the clinical engineers specifically to bring to bear really the strength of the engineering community, not just in London, but across the UK, to help support the clinical engineering at the Nightingale Hospitals. And that has resulted in over 1,000 engineers volunteering to help in this wonderful cause. Obviously, as we go through this Q&A, I'll be able to tell you a little bit more about what that actually means. So I'll leave it at that for now.
Thank you very much, Helen. Can I hand over to Richard now for a brief introduction to his role in the Nightingale Hospitals?
Well, thank you, Mark, and it's a great pleasure to be here this afternoon speaking to everyone. So as Mark said, I am the Professor of Biomedical Systems Engineering at Imperial College London, and the technology which we're going to talk about this afternoon is research that spun out of my lab at Imperial College about 10 years ago, although there have been significant further developments, of course, into Visbion, of which I'm one of the key founders and still chairman. What the technology does in relation to the Nightingale Hospitals is it allows secure medical image transfer, particularly CT images, across the network. So in the case of the London Nightingale Hospital, they can be stored in the information infrastructure at Bart's Hospital. This is an important aspect of diagnosis in terms of COVID-19 because patients in intensive care have to undergo CT scans, which give you definitive diagnosis of the pneumonia associated with COVID-19.
Thanks, Richard. If it's okay for both of you, I'm just gonna start off with some general questions that I'd like you both to answer. And it may sound a bit basic, but I think people may not realise quite how many engineers are involved and how much engineering is involved in setting up the Nightingale Hospitals. I was wondering if, in turn, you could both kind of paint a picture, really, of how much engineering is involved from start to finish of thinking about setting up a Nightingale Hospital and then getting it up and running in a clinical setting. Helen, would you want to start?
Yeah, absolutely. Well, I came into the Nightingale sort of almost when it had been built in some respects. So I was kind of at the back end of that. But the work that's gone into it to build it and set it up within the space of essentially 2 weeks has been phenomenal. And that has required engineers from a whole raft of different skill sets, from technicians right through to senior managers. As you're obviously aware, a lot of the engineers that helped set up the building in the first place were from the armed forces, and of course we have a big community of engineers within that within the armed forces who are able to do that sort of big logistical infrastructure build. So once they had really created that building, and hundreds of them were involved in putting that together, then it really came down to the clinical side, if you like, the medical side of engineering, and that's where I got involved with the engineers. Now, I kind of want to take you back a little step before we get to the engineering, just to put this into context, if I may. Engineering within the NHS sits within a community of healthcare science, and there are about 55,000 healthcare scientists in the NHS. Of that, there are probably only around 3,000 to 4,000 clinical engineers. So it's quite a small group. But within the healthcare science community itself, of the workforce, which is only about 5% of the overall NHS community, they make an impact of about 85% of all diagnostics that's done. So that just gives you an idea of the amount of work that goes in. Of that very small group of people, they have a huge impact on patient care. So right from the very start, we needed to make sure we had enough clinical engineers within the facility. The healthcare science is broken down into 4 areas. So clinical engineering comes under physical sciences, but we've also got the life sciences, which cover things like pathology and hematology, so blood sciences, those sort of things. We've got the physiological sciences, which cover things like audiology and critical care. And also the bioinformatics as well, where there are a few engineers within the bioinformatics community who look at things like health information and genomics. So across that whole range, there's a whole group of engineers and scientists working, but that one group of clinical engineers was where I was really focused.
And Helen, can I just follow up on that? What is a clinical engineer? Can you give our listeners out there, our viewers, a bit more of an idea of what skills do you have? What do you end up doing? What is that?
Well, a lot of clinical engineers actually come in through the engineering route initially. So there are training programs to go into the NHS to become a clinical engineer. So often we have engineers who have already done a degree in mechanical engineering, electrical engineering, or more commonly these days, biomedical engineering, which is a more recent degree course, but covers similar sort of topics, but focuses on the anatomy side. And so when they come through those routes, they also come through apprenticeship routes as well into the profession. And once they're employed within the NHS, they then go through a whole training program to understand both the technical aspect of what they do as engineers, but also the clinical aspect and how that relates to the human body and what they're involved in. So they could cover everything from rehabilitation, orthopedics, they could be designing technology within the hospital itself to help patients. And in the case of obviously the Nightingales, they've been involved in maintaining and commissioning a lot of the technical equipment that has gone into looking after patients. So it covers a whole remit of areas.
So things like these ventilators that we've heard such a lot about, I guess you'd have a clinical engineer who would be installing one of those, is that right? And making sure that it is functioning correctly before handing over to the doctors, is that correct?
Yeah, so the clinical engineers at the outset, and they would do this in their daily practice in under normal circumstances in the hospital, they would be involved in commissioning, acceptance testing, risk assessments, and then obviously repair and maintenance of those devices as well as over time. But it's the critical care healthcare science which deals with the bedside side of things. So there's a slight difference between the two, but the critical care healthcare scientists are really working alongside the doctors and nurses to routinely perform functional checks, those sorts of things, and make sure that the devices are working whilst they're attached to patients. But it's the clinical engineer's job to ensure that they are fit for purpose.
Thank you. Helen, can I just switch over to Richard and just ask him from a different perspective now? Helen's been telling us about how they get hospitals get set up and are starting to run, and then of course your technology is involved in taking the images and the data from that and transferring it over to a hospital setting securely, if I'm right in thinking that.
Yes.
Can you just paint the picture of the time you get the phone call? We're going to start these Nightingale hospitals. We're going to need to do this. Can you help? What happened next?
Okay, well, I mean, the key point to understand is that this is the tip of a very large iceberg. I mean, in relation to the Nightingale Hospital at the Excel Centre, all the images and other data were sent right back to Barts. And there in Barts, there's an extremely complex information infrastructure which has been created over many years. And we have been part of those kind of integration systems. So when you look at this in the context of the Nightingale Hospital, the way that this works is that there are these large mobile trailers, which are like, a sort of large lorry, which has within them various kinds of scanners. And that's where they acquire the images and where they interface with the patients at the Nightingale. What our technology does is to interface with the scanners. It then takes the images and other data, it encrypts it using military spec encryption, also compresses the data so that it can be transferred across the network to, in this case, the Barts. And then what happens at Barts is that, and that's done by a device which is a piece of a physical device called an image cube, which has within it sophisticated software, which is based upon an international standard called DICOM. And at the other end of Barts, there's another physical image cube which de-encrypts the data, unpacks the data so it's lossless encryption, and then puts it into exactly the right place within the information system within the hospital. So, if you were trying to do that in terms of a new hospital without these trailers, etc., it would take maybe 1 or 2 years to be able to do that. But it's because you have this technology whereby you can literally drive in one of these big trailers and then we connect it up to the trailers that were installed in the Nightingale Hospital, and our software automatically transfers all the images and other data over to Barts and then de-encrypts it.
So does that mean that the trailers already existed prior to this? And I guess what function do they play in the normal running of a hospital?
Okay, so there are various imaging modalities, as I'm sure you're aware. So there's CT, which is what's used at the Nightingale at the moment, magnetic resonance imaging, ultrasound, etc. And what happens in, let's say, London teaching hospitals is often that their scanner capacity is not adequate for the number of patients that are going through. So what they do is they hire in from large companies like Alliance Medical or Siemens or whatever, one of these large trailers, which, as I say, is like a big articulated lorry. And inside that are the scanners which they can use. So it gives them additional capacity. Yeah. And the advantage of these trailers is they can be moved literally with a day's notice to some other hospital, providing they have the kind of technology that we provide, where you can connect directly into the information system of the hospital. So this is, if you like, a developing trend, I would say.
So from a not just from a COVID-19 perspective, but from an NHS perspective, what this allows hospitals and the organisation to do is to expand and contract the amount of scanning capacity it has on within a few days. I mean,
within a day actually.
Incredible.
So the hospital just calls up one of these trailers with a scanner, it arrives, our technology then connects into the information system of the hospital and everything runs smoothly. And by the way, there's no physical interaction there. It's all done electronically, which means there's no problem with infection or anything like that.
And presumably when you started the company 10 years ago, you could see the need for this. Is it particularly to do with the mobile nature of this and the expansion and contraction, or is that a subset of what you do?
No, that's a subset. I mean, at the core of what we did originally and what's been going on for 10 years is the integration of all these different kinds of images into a common information environment where the clinicians can view the multiple images, they can store the images, etc. And at the heart of this is this international standard called DICOM, Digital Image Communication in Medicine, which is what everybody uses internationally. And what we did, the core of what we do in terms of our technology is that we wrote a full DICOM library, as it's called. That's the software that implements the international standards. And that took 10 years to write, actually. So it's very extensive. It's over 1 million lines of code. And that's embedded, believe it or not, in our data cubes that sit in the hospital.
Thank you, Richard. If I just go back to Helen for a minute. So then, if we think about that, so what we have is obviously this expanding and contracting, and in the case of COVID-19, this expanding Nightingale Hospital facility using Richard's code and software. These trailers are coming in, but it needs engineers to man them, and that's where you come in. Is that right, Helen?
Yes, that's where the clinical engineers really come to the fore, and they work with, in that particular case, with the CT scanners. They work with the radio therapy physicists and the nuclear medicine team, obviously in that sort of area. But yeah, they would be working with those sorts of pieces of equipment. They would predominantly be working with equipment at the bedside. So things like life signs monitors, the ventilators, obviously we've talked about, but all of these sorts of pieces of mobile equipment. And as Richard rightly says, the technology that has been at Barts, as some of that has been moved to Nightingale to enable these sorts of things to occur. And I think it's that flexibility, I think, of the technology and the engineers that support that technology, which has really made this whole thing possible, really.
And talking about the volunteers who've made it possible, I mean, so these are volunteers that you've managed to kind of recruit, and they actually otherwise would have been employed. So these are people who are essentially kind of on furlough, I suppose. Is that right? Or
Yes, many of these were engineers very early on. I mean, within the first 24 hours, we had 600 people sign up to the database, which the Royal Academy of Engineers kindly helped us to create that database. And with their help, we were able to communicate with all of the engineering professional institutions. So it went from me at the IMechE to being able to engage with all of the engineers across our entire community, to ask them if they could help. And they offered their services in different ways. Some were able to do that part-time because they were still working. Others, as you rightly said, have been furloughed, so they were able to give their time more freely. But each of them, were able to give their time, and eventually, as we have now, we're just over 1,000 people on that database.
So I've got some questions from the public about this specifically. Can I just read you a few, and you can see if you can answer some of them? Stephen Moore is asking, how much cooperation did you need from their employers? Did you have to contact those employers to allow them to work? And also, will this continue as more firms open up? Is that a worry? And there's another question here, which is related to what you've just been saying, from Tabby Davis, who says, are the volunteer engineers a 24-hour team, and how does that work? Perhaps if you could just have a go at those two for the moment.
Yeah, sure. So, obviously the people are volunteers, and obviously some of them are still working. We had quite a number of volunteers actually come as companies. So it was really nice to hear from their senior managers who said, you know what, we know we can't be doing the work that we would normally do. How can our engineering company help you? And so that in itself was really quite amazing, that companies were happy to volunteer their entire engineering staff. Where individuals volunteered, obviously we encouraged them to speak with their employers before they signed up. And we also had to go through a very strict process of creating a job description that they were signing up to. This was not just something that we've said, hey, let's bring everybody together and do this because it's jolly fun. There was proper engineering thought and process going into this right from the start before we even got to the database. So we created a job description, we created a criteria which we wanted to select engineers from. And this is why we approached the professional engineering institutions in the first place, to ensure that we had people of the highest standard and the highest quality to be part of this this process. So yes, we encourage them to speak with their bosses first. In terms of,
I suppose it's worth saying that that's one of the things that engineers are very good at, isn't it? Creating systems and processes to make things happen, not just once, but to happen over many times reliably. And as one of our questions is asking, 24 hours presumably cover.
Yes, the teams themselves are actually set up in shifts, so that they are obviously there 24/7. But the teams that the volunteers we've put forward specifically are working in shift patterns, and obviously we've had to make sure that those that were volunteering who could only work part-time or weekends, that they could provide their services, but also think about their own time and commitment as well. So yeah, we've had to work around a lot of people. Yeah.
Thank you. Could I just remind everyone out there who's viewing and listening that if you want to ask questions, this is the whole point of this, isn't it? To have these amazing people able to answer questions live, just click the Q&A button at the bottom of the chat and post your question, and we'll try and get through as many as possible. I want to just turn to Richard if possible. And Richard, we got some questions here about working alongside the military. I don't know, are there different protocols in terms of the data? Does the military use your data? Oh, sorry, your software, and was there any issues there? This is from
well, I mean, the military in the context of the Nightingale Hospital was, if you like, two separate areas of activity. But our technology is also embedded in various military medical systems. Yes. And that's not just in this country, but that's around the world. So we actually have 1,000 systems in 10 countries. So, what was implemented at the Nightingale Hospital, whilst being customized for that particular requirement, is based upon, very, what I would say, standard and well-tried technology, which we've applied in other areas.
Thank you. And sorry.
Yeah, I was going to say, so for example, one example of that is, another NHS example is that we run all the imaging for the national breast screening system within the country.
And has that got a mobile element as well?
Oh, absolutely, yes. I mean, so the breast imaging is typically a mobile operation within the community. And so what we do is the images are acquired, and then our technology transfers the data and the images to the appropriate hospital database automatically.
So you're painting a picture, Richard, of something that you were kind of, that this country, and in particular the organisations and parts of the NHS that you're involved with were pretty ready for, in terms of kind of upping sticks and getting this to happen. Helen Ewells is asking if there were any regulations or processes that had to be accelerated in order to make the Nightingale bit of it work.
I don't think there were any particular regulations that we had to meet in relation to the Nightingale. because there are all manner of regulations that you have to go through, and checks and balances, etc., in terms of the normal hospital information systems, which we as a company had to go through over several years. So that was already in place, and therefore, implementing this from a governance point of view into the Nightingale Hospitals was pretty straightforward.
Thank you. Can I switch back to Helen? Helen, we're getting some questions about the different disciplines that you were trying to recruit, and perhaps are still trying to recruit. If that's this is from Anonymous, actually. Hi. What engineering disciplines are you interested in when you're creating the team and the volunteers?
Well, we used the criteria and the job description and skill set that the clinical engineers themselves had, and we used that as the basis from which we created this auxiliary engineering support engineer that we named them. So that was our first focus. We specifically then looked at, and in our database we created a skill set, if you like, from that we asked the engineers who were volunteering to take a look at and to identify which ones were relevant to their skills themselves. So it covered everything from electrical, electronic, PCB diagnostics, right through to building services and sort of gas and air delivery. So it covered a whole range of the sorts of skills that clinical engineers and the wider engineering community in the NHS would have, and that enabled us then to specifically select engineers from the database as and when different sorts of skill sets were needed.
I mean, specifically, I'm being asked by Fan Wang if your team, or if you know of the engineering team who had to kind of work out the ventilation system for the new hospital, the Nightingale Hospitals, because as I understand it, they're all in different locations with different setups. Is that anything that you've been involved with, or your team?
Not, I'm afraid. So I wouldn't be able to answer that question. But yes, I mean, it's when you're bringing in new equipment in any type of equipment, the complexities of bringing that technology into a new environment and to identify what the setup is really huge, and took an awful lot of time and effort. But I wasn't involved with the implementation of the ventilator system, so I couldn't really answer that specifically.
Do you get a sense, Helen, that something will have shifted in terms of the profession of clinical engineer? Do you think you've got more visibility? Do you think there'll be a much greater uptake? I mean, I don't know if there is a skill shortage in general in clinical engineers. Is there? And do you think that this will have an impact on that?
I think you've hit my soapbox moment really there, Mark. It's something that I've been very passionate about raising the profile of for many years now. As I said right at the beginning, of the community of healthcare scientists within the NHS, they only make up a small percentage of the workforce, and the engineering community is even smaller than that. So yes, I think as we come out of COVID and perhaps deal with new problems in the future, I think we really have recognised, and I think the wider society has recognised, that engineering is fundamental and ubiquitous, as Richard has already said. With his technology, you can't go into a hospital and not be touched by a piece of technology from one end to the other. And so it's very important now that we raise the profile of engineering within the medical community and the healthcare community, but also we need to raise the profile outside of that to wider society, to show people how important this profession actually is, and the opportunities of coming into it as a profession, which are just fantastic.
And about that, I mean, I think people may think that they have to do a very traditional engineering, or what they might imagine as being a very technical engineering degree, which they might feel intimidated about. Is that true? Is the only route in through a university degree and then to go on through there, or are there other routes to become a clinical engineer?
Well, there is a National School of Healthcare Science, which they have evolved the programs and the curriculum for the training of clinical engineers and the other healthcare science fields over many years now, and you do your training through that. There are three different routes in, really. There's the engineering route, which is the degree route, if you like, and it's normally expected that you would have an engineering discipline qualification as you go into that. But there is an apprenticeship stage as well, so you can actually come into the field of clinical engineering through the apprenticeship route. And certainly for young people who are looking for a profession in engineering, that would be a fantastic opportunity to explore an apprenticeship within healthcare and certainly within the NHS. And then as you progress through your career, there's also the route into consultancy as well. So you develop your standard and your standing within the profession and go into consultancy level roles as well as clinical scientists.
I think that would be, I mean, I think that's one of the things, isn't it? We need to make it clear that there are many different routes to having these jobs that are absolutely crucial to things like COVID-19, but beyond this, the whole running of the NHS, and that there are many ways to become a clinical engineer.
Absolutely, yes. There are a lot of opportunities, and in fact, I know of some of the volunteers who are recent graduates of biomedical engineering degree courses who've put themselves forward to be volunteers. This wonderful opportunity before they even start their professional career, to be able to give their time to support the clinical engineering service. So yes, there's some great opportunities, and it's certainly something that I think we need to make more of in the public domain, to understand the importance of the technology that goes alongside patient care.
If I could switch to Richard, there's a question here from Stephen Morn who says that he was asking about whether the image data sharing systems, information sharing systems that you have developed, are they applicable to a wider set of NHS IT issues?
Oh, absolutely. I mean, so within the Nightingale, we were only talking about CT. But our technology works across all the modalities, so MR, CT, ultrasound, etc., and even things like physiological waveforms like ECGs, and it integrates all that information into a common imaging platform or a common viewing platform. But it also stores all the information in what's called a vendor neutral archive. So when you're dealing with equipment from multiple manufacturers, we can deal with all the different formats of different manufacturers automatically. And another important aspect of this is, of course, is that we can now allow, for example, radiologists to work from home, so they can actually access from their homes all the images using this kind of technology.
And presumably there's an international angle to this, that actually it doesn't really matter where these trucks are in the world, as long as they have internet access, the clinicians can help.
Yes, absolutely. I mean, I see this a bit like the development of almost like the national grid. I mean, as load comes on in a particular hospital, or even in a particular hospital within a different country, you can then switch the load using this kind of technology. You can bring in a mobile trailer, then For example, radiologists, even in California, can then read the images using this technology. So it is very, very universal, very international. In fact, I mentioned earlier that we have 1,000 systems in 10 countries, and we monitor all those systems. Well, our technology monitors all those systems automatically. So we do have installations in, for example, Los Angeles, and when those systems go down, maybe overnight, if there's some problem overnight within the hospital there, then it's often corrected automatically by us before they even get up in the morning.
Amazing.
Yeah.
And presumably, this is perhaps not, this is going a bit further, but presumably the bottleneck isn't the diagnostic bit. Is it the bottleneck in these? Is access to the ventilator or the oxygen supply? Is that right at the moment?
That's within the COVID context. Yes, yes, that's right. And it's important to remember that when they built the Nightingale Hospital, which we of course were not responsible for that particular aspect. I mean, all the gases, etc., had to be plumbed in properly, as in another hospital like Barts or the Royal London, etc. And that's really what took all the time. So, within the Nightingale Hospital, you are talking about a really full spec intensive care hospital.
And in terms of IT, which is what your technology depends on, is that also? I mean, presumably they already had Wi-Fi, but I guess you had to up-spec that, or?
Well, actually, in relation to the Nightingale Hospital and Barts, we went across the normal telecommunications network. So that was a normal broadband network. However, when we're dealing with issues like the national breast screening application, then that actually the technology works across the 4G network, so the mobile phone network, and that represents or has represented a whole series of additional problems which we had to solve, and that they have been solved, and the whole system now works routinely in multiple sites across the country. So within the context of the Nightingales, it is done across the wired network, but the technology also works across the mobile network.
Can I ask you, Richard, if you perceive there to be a skills shortage in your area of engineering, and if so, what message would you like to send out?
Well, I think that Helen sort of touched upon this. It's not so much a skill shortage as we need more people working in these areas. And I mean, lots of people can work in these areas if they come from a software background or a general engineering background. There are lots of different applications. The other thing that's really important to say is that in terms of the people that we're involved with, in terms of our engineers, etc., this is an area where female engineers are now beginning to play a much bigger role, and that will expand. There's absolutely no reason why female engineers can't take part in any of this. I mean, and that's one of the exciting things about these developments.
And I'm being asked a question here about what it's like for you as a small to medium-sized business working within the NHS. I mean, we hear lots of issues around the barriers to integrating with such a big system.
Yeah. Well, when I'm asked that question quite often, and the first thing I say is, well, you have to realise that the NHS is the 5th largest employer in the world. So you're talking about, if you talk about the Chinese army, Walmart, etc. We're actually the 5th largest. The NHS, the 5th largest employer in the world, with about 1.9 million people. So clearly that's going to cause a problem fundamentally. So the question is, how does a small and medium-sized company address that issue? And the way that we would recommend people do it, and certainly the way we did it, was to work with larger companies to make them realize that we had technology which was important to them. That's one route. The other route is to work with individual trusts and to solve problems that individual trusts have. Because once you've solved a problem for one trust, they tend to talk to lots of other trusts, and they take up your technological solution. And the difference between an SME, a small and medium-sized company, and a large company is that we can be much more flexible. We can provide niche solutions to particular problems. So there are ways in, but it's by no means straightforward. The other point is that, of course, you have to then deal with all the accreditation hoops that you have to jump through in order to be fully accredited and to be recognised by the NHS to be a reliable supplier, and that typically takes several years. So,
from an innovation and entrepreneurship sort of angle, then, I mean, essentially, you're innovating not just in your technology, but you're also innovating in how to reach the different bits of the NHS.
Yes,
really.
That's right.
and talk to the right person, right? Because that's an issue.
Yes, I mean, I remember 10 years ago, one of the health ministers said to me, the problem with the NHS is it's how do you find the front door? And I mean, I think that's fairly true. I mean, it's not that people are not receptive, but it's a question of how do you get to the right people. And as I say, I think the way you do that is working with larger companies and also working with the trusts.
Thank you, Richard.
I think if I might add to that,
Helen, go ahead. Yeah.
That there's obviously there are a lot of organisations now that are helping the NHS to develop technologies in their own right. Obviously, we've got the accelerator programs, the AHSNs, and so on. But I think this is where we have a real opportunity to embed the clinical engineering community to help the procurement teams and the supply chain within the NHS to not only develop new technologies, but to find people like Richard to work with, to develop ideas directly in the trusts themselves, and that community of engineers then can spread that technology. As Richard rightly pointed out, once you work with one trust, you've then got to try and convince other trusts that your technology is equally as valid, and that can be quite time consuming. But if we had a bigger network of engineering where we could spread best practice in a much broader way, we would be able to overcome some of those barriers, I think, in the future in terms of technology adoption.
I guess this comes also... go ahead, Richard. Yeah.
No, I was going to say, I think another aspect of this, which is really important, is to get more engineers on hospital boards. I mean, I won't mention any names, but I was on the board of one of the London teaching hospitals for 8 years. They were pretty open. But, it was fairly, and I was there, of course, but it was fairly obvious that there is a real need, because of the high level of technology in hospitals today, that you really need engineering expertise on the board that can, really explain the strategy and why particular types of equipment are needed.
Yeah, I think I would definitely support that as well, Richard. I think certainly from an IMechE point of view, we've been campaigning on that very issue for many years now. We need to see chief engineers on the boards of every NHS trust in the UK to ensure that it's at the same level and parity and given the same strategic objectives as other parts of the NHS. And that is something, it's nice to hear Richard say that he's been part of that, but it's not common. And we do need to be encouraging engineers to get to that senior board level in order to make those strategic decisions on technology.
I guess this comes to another thing, maybe a misunderstanding about engineering, which is that it's very much a people's profession. It's about people, and in the context of medical and hospitals, it's about people saving lives, but it's also about having good communication skills to get into those positions of influence. And I think that's often not taken into account in the training.
The training of engineers.
Yes.
Yes, but of course that's changing rapidly now. I mean, every engineering degree course that you see these days includes transferable skills at a fairly high level because of that particular issue. I mean, not only in the medical context, but in general. I'm sure you would agree. It's extremely important that engineers are able to articulate exactly what it is they need to get across.
Yes, thank you. Richard and Helen, we're going to have to sort of finish up now, and I'm going to invite you in a minute just to give your final closing remarks, some of which I think you may have already touched on. But before I do, just want to seed your thoughts with a few final questions from the public. There's a few here we haven't answered, but don't feel you have to be encyclopedic in your answers. One from Anonymous, which is the volunteering process for Helen and the Nightingale Hospital still going on? Another one from a graduate biomedical engineering student who's about to graduate, saying that they have volunteered but they're still waiting for an allocation. Is that something you can comment on? Here's one from Alex Reeve.
I can answer both of those very quickly.
Okay.
The first one is that we have frozen the volunteering process for now. Obviously, some of the Nightingale hospitals are now in a holding pattern, as it were, because the surge has been lower than we expected, which is wonderful. So we're holding that database for now. So we haven't taken any more volunteers as yet. Those volunteers that have signed up, obviously, that kind of answers their question, that until we get calls from the various Nightingales and the trusts, we obviously won't be allocating any other engineers, but obviously once that starts to happen, then they will get a call. We'll be in touch with them. So we thank them very much for volunteering, and we'll hold on to them for a while.
Okay, so if I could ask you both, I'll ask you, Helen, first, and then Richard, for some closing remarks. The one question I really wanted to ask you both was, what are you going to take away from this experience in a post-COVID world? We've actually touched partly on that in our discussions about skills and recruiting people, and how a lot of this technology is already embedded. But I wondered if there's anything else you wanted to say about that question, and if not, anything else you wanted to say about what you've learned having done this.
I think for me, it is the incredible flexibility that engineering demonstrates in times of difficulty, and its ability to address problems in the most extreme situations. And that for me was, the real thing that I think I will take away from this, that I always knew I'd come into a profession that could challenge every barrier that was put in front of it, but this has shown really what engineering can do in extreme situations. For me, I would like to see more clinical engineers coming into the NHS, and certainly more engineers coming into the medtech and healthcare profession. And I hope that this kind of webinar and other opportunities where people see what engineering can really do to solve healthcare problems, I hope that they will take up that challenge and go forward into this profession, because it's amazing.
I think for me, what I would take away from this is that within the context of the COVID crisis, the only way that it's been possible to really set up the Nightingale Hospitals and to do all the sort of things that we've been doing is because there's been an enormous amount of background work that's gone on over many years. I mean, the analogy that I might want to use is Alan Turing and the Enigma code. It was only possible for Turing to crack the Enigma code because of 10 years of work that had gone on before that. And I think in general terms, that's true here in terms of engineering in this and other contexts. It's because of all the groundwork, the reliability, reproducibility that goes into engineering that makes it so extremely reliable. And I think that the other point that I've learned from this is that I believe that in the future of the NHS, specifically the NHS actually, because I think we have a fantastic national system, it's the whole ability to be much more flexible and to bring in facilities when you really need them, and particularly in relation to the ability to, in our case, the ability to image within the community. So that I mentioned the national breast screening system. I mean, the breast imaging is done throughout the whole community. These trailers just move around the country. Women can be imaged, in their local environments, and I think that's extremely exciting and very important.
Thank you, Richard. Thank you, Helen. Really, it's been an absolute honour and pleasure to talk with you today. And I've learned such a lot. And mostly, I think I want to kind of echo what you both said, which is that it's just hugely impressive to hear about the engineering detail of what's been achieved in such a short period of time, and that is a testament to the depth of the engineering infrastructure and skill sets and entrepreneurial talents that we already have in this country. It's a hugely powerful engineering community in the UK, and I think the setting up of the Nightingale Hospital has just shown that through and through. It's just been a 100% success, and the flexibility and the entrepreneurial spirit and the innovation that we can see is really truly impressive.